Yeah, in today's class, I'd like to go for fourth unit of our syllabus. Okay. Yeah. Good morning, Rakshita. Good morning, Svetanjali. Okay. So the fourth unit of our syllabus is preliminaries of functions of several variables. Preliminaries of functions of several variables means introduction of functions of several variables. Functions of several variables. Okay. See, as we have discussed that means up to this unit we have discussed like the functions of single variables. Okay, so from childhood onwards you are learning about what about e power x, what about log x, what about sin x, okay na, what about cos x, okay na. So these kind of functions like the graph what it will be, the graph what it will be, what is the domain of this, what is the range of this, okay na. So what is the derivative of this, okay na. So what is the integration of this, okay na. So this kind what is limit of this, limit of x square, limit of 1 by x, okay na, at some particular point. These are all we have discussed. Means you are learning from childhood onwards. Like in PUC, mainly in PUC, you have learned more. Okay, about functions of single variable. Okay, so like what is the limit, what is the derivative, what is the integration, what is the curve, what is the domain, what is the function. These are all. These are all. Okay. So how it will be happening. Okay. So where it will be vanish. What is the critical point? What is the singular point? Many you have discussed. Okay. So have many you have learned. Many you have learned. Okay. So now we are going to be discussing that the functions of several variables means the function of 2 and 3 variables f of x comma y, f of x comma y comma z, what it will be, what it will be. Okay. So that's what we are going to be discussing in this class. Okay. So that's what we are going to be discussing. So in this class. Okay. So how the graphs means in this whole unit. Okay. So what about that? No functions will be happening. What about the graphs of that? Okay. So under the whole unit, we have discussing what is the derivative of that. Okay. Na? What is the partial derivative of that? Okay. Why it is happening? Okay. So what is the derivatives will be happening? What are the some properties of derivatives? What about maximum value? What about minimum value? Okay. What about maximum value? What about minimum value? So that are all we are going to be discussing. So in this functions of several variables, the functions of several variables. That is our aim is to go. Our aim is to go. Okay. So actually, as you know that a real number means that which is a line, right? Which is a line. Okay. So having like some uh, zero here, having like zero here, plus one, plus two, plus three, plus four, and so on. Similarly, minus one, minus two, minus three, so on. Okay. Na? So what about R square? What about R square? Anyone? Is R cross R? What is R square? Anyone?
Same values of R.
What?
Positive
Square.
values.
0 to infinity, sir.
R square is nothing but R cross R, nothing but the points in a plane. Points in a plane like x comma y, 1 comma 2, 1 comma 2, 1 comma 3, 1 comma 4. Okay, na? 2 comma 1, 2 comma 3, minus 1 comma 2, whatever. Okay. So the points in the plane represented by R square. Okay. Means this nothing but the points are taken by ordered pairs. R square taken by like x, y, such that x comma y is in R. X comma y is in R. Okay. X, y such that x, y, x comma y is in R. Okay. Na? So similarly, R cube. What is R cube? R cross R cross. Nothing but order triple. Order triple. Okay. So the points in a space means that the points in three-dimensional, right? The points in three-dimensional. Okay, now the points in three-dimensional. Okay, now. So similarly, r power n will be there. R power n, r cross r cross r cross, and so on. Cross r n times, n times. Okay, which is nothing but like x1, x2, x3, and so on, xn. Okay, where x1, x2, and so on, xn is in R. So which is n dimensional, which is an n dimensional plane. This is an n dimensional plane, okay? Or n dimensional space, okay? So this is a line, this represents a line, okay? And this represents a plane, you know that plane, xy plane, okay, now xy plane, okay, now xz plane, yz plane, like that, okay? Whatever you like, you are treating that xy, that is xy plane. You can treating that xz, that will be xz plane, okay? And this is a space, three-dimensional space. We call it as a space because of we are able to see any object in three-dimensional only. So that's what we call as space, okay? So there will be a four-dimensional, five-dimensional also, but we are unable to see that, okay? So in 3D also, we have to see, cinema చూడాలన్నా కూడా, you know that 3D cinema చూడాలంటే ఏం చేయాలి? We have to use some separate glasses, right? So likewise, we have to, like similarly, we have four-dimensional, five-dimensional, n-dimensional also. Okay, but we are unable to watch by our eyes, or human eyes. Okay, okay, this is n-dimensional space, n-dimensional space. So Euclidean has introducing this. That's why it is called Euclidean space. Euclidean has introducing this. That's why this is called Euclidean space. Euclidean n-dimensional space. Okay. Euclidean n-dimensional space. Okay. Mic on చేస్తున్నారు కనబట్లే. Okay now distance between 2 points in a plane తీసుకున్నాం అనుకోండి, distance between 2 points. Distance between 2 points. Okay. ఒక plane తీసుకున్నాం అనుకోండి. ఒక plane just a moment. So what is the distance between 2 points in a plane x1, y1 and x2, y2, anyone? What is the distance?
Root of x2 minus x1 whole square plus y2 minus y1 whole square.
Very good. Very good. Okay. Na? So similarly for three variables in three-dimensional space. Three-dimensional space. Anyone?
Root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square.
Yeah, very good. So if x1, y1 will be there and x2, y2 will be there, A point and B point, x2, y2 will be there, then distance is D, square root of x2 minus x1 whole square plus y2 minus y1 whole square. If A is x1, y1, z1 and B is x2, y2, z2, and D is root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. So similarly, n-dimensional, A, x1, y1, x1, x2, like to take x1, x2 and so on. And so on xn, B I would like to take y1, y2, so on yn. Then what is D? What is D? Okay. D is y1 minus
y1.
Yeah, x1 minus y1, both are same. Okay. Y2 minus x2 whole square and so on. Y1 minus xn whole square. Okay. So this will be written as summation y1 minus yn minus xn whole square, or yi minus xi yi minus xi whole square, I equal to 1 to n. Okay. So this will be nothing but summation I equal to 1 to n xi minus yi whole square. Okay. So nothing but distance between this is a, this is b, this is b, distance between 2 points in any direction. Okay. So like this only one direction it will be, like it is a curve. Okay, it is a straight line. Okay, it is a straight line, right? Okay, no, this is a straight line. Okay? Similarly, A is a point in n-dimensional, B is a point in n-dimensional. Okay, B is a point in n-dimensional. Okay, so the distance between that 2 points that will be taken by this. Note down clearly. Note down the distance between n-dimensional space, n-dimensional space. The distance between that 2 points taken by like this. Okay, na? That distance between 2 points will be like this. Okay, na? Now, now చూడండి please. Yes, please చూడమ్మా. This is very important for our concept. Neighborhood of a point. Neighborhood of a point. Please listen carefully. Neighborhood of a point. So this is denoted by NBD of A. A is any point. Okay. Capital A or small a, don't worry. So generally, amma, neighborhood of a point means that, for example, real line తీసుకున్నాను అనుకో, real line. So 2 is a point, 2 is a point, a small radius of 2, a small radius of 2, all the points, okay, that points are called set of all points, okay, small radius of 2, that we'll call it as neighborhood of 2, like from 1.9 to 1.9 to 1.9 to 2.1. Okay, when we take epsilon as 0.1. When we take as epsilon as 0.1. If I take epsilon as 0.2, then 1.8 to 2.2. Okay. If I take epsilon as 0.001, epsilon as 0.01, okay, epsilon as 0.01. Okay, then what is the neighborhood? 2 minus 0.01. Okay. So 1.99 to 2.01, right? 2.01. Okay. Okay. So epsilon is 0.001 when we take, that will be 1.999 to 2.001. So that all set of points, okay, that all set of points. How many points in between these? So interval any points on time? 1.9 to 2.1. How many points in between this? Anyone? How many? In a word, infinity points.
Not countable, sir.
Yeah, infinity points ఉంటాయి, infinite. Okay, infinite points ఉంటాయి, infinite. Okay, infinite points ఉంటాయి. Okay, so that is what neighborhood. Okay, there exists an epsilon greater than 0, such that x minus epsilon to x plus epsilon is called neighborhood of, it's called NBD of n delta or n epsilon of n epsilon. Okay, when we take delta, that will be denoted by, there exists delta greater than 0, such that x minus delta to x plus delta, so that is n delta of Okay, now the screen is visible.
Sir.
Visible, sir.
Yeah, so that is about the neighborhood of A. The same thing when we take in two-dimensional, when we take in two-dimensional. Okay, suppose my point A is, okay na, small a తీసుకుంటాను. So like x1 y1. Okay na, so I can take epsilon as epsilon1 epsilon2. So the distance between these 2 points is okay. So what is the distance between a comma epsilon? What is the distance between a comma epsilon? Okay, so root of x1 minus epsilon1 whole square plus y1 minus epsilon2 whole square, right? So or you can take, see, ఇప్పుడు మీరు చూస్తారు. So a అనే పాయింట్ తీసుకున్నాం x1 y1, So that will be A, okay, x1, y1. So then your neighborhood in case of two dimensional, not only from left side, not only from right side, okay, not only from left side, not only from right side, okay. So that will be all directions, okay. In case of real line, okay, so in case of real line, okay, in case of real line, that will be a only straight line, okay, only straight line, real. ఇక్కడ పాయింట్స్ ఉండవు అంటే రియల్ అయితే అదే బట్ ప్లేన్ లో అయితే ఇన్ కేస్ ఆఫ్ ప్లేన్ ద పాయింట్స్ ఆల్ ఆర్ పాయింట్స్ రైట్ ఇవన్నీ కూడా పాయింట్స్ ఇవన్నీ నాట్ ఓన్లీ దిస్ ఓకే ఆల్ ఆర్ పాయింట్స్ ఇవన్నీ కూడా పాయింట్స్ అయ్యి సో మనం మన రిక్వైర్మెంట్ బేస్ చేసుకుని ఒక ఎప్సిలాన్ రేడియస్ లో తీసుకుంటాం ఓకేనా ఎప్సిలాన్ రేడియస్ లో తీసుకుంటాం ఓకేనా సో దట్ విల్ బి డినోటెడ్ బై ఓకే అర్థమవుతుందా will be a what is now this is called what is now this is called దీని ఏమంటారు ఇట్ ఇస్ a circle in case of okay so మనం ఇప్పుడు దీన్ని స్క్వేర్ చేసాం అనుకోమా ఏమవుతుంది x1 minus epsilon 1 whole square plus y1 minus epsilon 2 whole square okay equal to some r square okay like that okay so write down that will be neighborhood of a point in a plane NBD of A in a plane write down that so let a equal to a1 a2 is any point be any point okay in r square okay and delta greater than 0 the delta neighborhood of a point the delta neighborhood of the delta neighborhood of point okay point delta neighborhood of point A is n delta of A okay or n delta of P okay n delta of A or n delta of P point P A or sorry small disturbance network issue okay So this n delta of A is n delta of P, okay? N delta of A or n delta of P, okay? So that will be nothing but A1, A2, sorry, x1, x2, x equal to x1, x2, okay? In R square, such that d of x comma A is less than d of x comma A is less than delta. Okay, so means that you can able to find. So this is my point A, amma. This is my point A. If we are find some other point of x, so the distance between A and x is always less than delta. Okay, this will be open interval, amma. Open interval. Okay, na? So we should take like this. Okay, na? So if you want to find neighborhood of A, if you are able to find a point x such that we are able to find a point x such that, okay, so the distance between A and x is always less than delta. It's always less than delta. Okay, so the set of all that points, okay, is called as the neighborhood of A. It's called as neighborhood of A. Okay, so what it will be? So the name under. So this is a circle, right? Which forms a right on ఇక్కడ కింద రాసుకుంది. సో లేదా మళ్ళీ దాన్ని రాదు. సో దీన్ని ఎలా రాయొచ్చు ఇప్పుడమ్మా? దీన్ని ఎలా రాయొచ్చు? X equal to x1, x2 is in R square, such that square root of x1 minus a1 whole square plus x2 minus a2 whole square less than delta. Okay na? So అంటే ఏమైంది మనకు? square root of x1 minus a1 whole square plus y1 minus x2 minus a2 whole square is less than delta. Square చేసాం అనుకోండి, x1 minus a1 whole square plus x2 minus a2 whole square is less than delta square. So what it will be? Anyone? Which is a circle. Okay, means that in the neighborhood of R square, any point in the R square, it forms a circle. Okay, similarly in case of R cube, the neighborhood of any point in R cube, NBD of any point in R cube, okay, this forms a sphere. Okay, okay. Any neighborhood of a point in R cube, okay, forms a sphere, ball, okay. Sphere అంటే ఒక బాల్ అమ్మ, సర్కిల్ అంటే ఒక బ్యాంగిల్ ఎలా ఉంటుందో దట్ ఈస్ కాల్డ్ సర్కిల్. ఓకే, బాల్ తీసుకెళ్ళి మనం పెట్టామంటే ఒక 3 dimension స్పేస్ లో దట్ ఈస్ కాల్డ్ స్పియర్. ఓకే, బాల్ తీసుకెళ్ళి క్రికెట్ బాల్ తీసుకెళ్ళి పెట్టామంటే దట్ ఈస్ కాల్డ్ స్పియర్. ఓకేనా? సో నథింగ్ బట్ NBD of R cube of A equal to x1 y1 z1 x1 y1 or a1 a2 a3. Sorry. Okay, NBD of A in R cube, as n delta of A, okay, equal to n delta of P. That will be, here also you can find x such that x1, x2, x3, such that d of A comma x is less than delta. This is nothing but x equal to x1, x2, x3, such that square root of x1 minus a1 whole square, x2 minus a2 whole square plus x3 minus a3 whole square, okay, is less than that. Okay. So similarly the neighborhood in n dimensional, okay, the neighborhood in n dimensional, n of A equal to a1, a2, and so on an. Okay, n delta of A is n delta of A, that will be n delta of P. Here also like to find X such that X1, X2 and so on Xn. Okay, such that D of A comma X is less than delta. But what is the D that, what is D that in case of n dimensional? What is D that in n dimensional, anyone? Square root of
Root of
x1
summation
minus
of
x1 whole
xy
square
minus.
plus a2 whole square and so on, right? So that will be nothing but, sum of I equal to 1 to n xi minus ai whole square less than delta. Sum of I equal to 1 to n xi minus ai less than delta. Okay. So this is called neighborhood of any point in case of plane, in case of space, in case of n dimensions. In case of n dimensions. దీని యొక్క షేప్ నాకు తెలియదమ్మా, n dimensional space. ఓకే, సో ప్లేన్ లో అయితే బ్యాంగిల్ అని తెలుసు, స్పేస్ లో ఆర్ క్యూబ్ లో అయితే స్పియర్ అని తెలుసు, n dimensional నాకు తెలియదు. హౌ వి నో? వి డోంట్ నో, రైట్? అవును కదా. So that is about neighborhoods, very important concept to do in limits, derivatives and all. Okay, please note down carefully. Hope you are all getting my point, right? Is it okay?
Yes, sir. So what does delta represent, sir?
Ma? Delta, epsilon in తీసుకున్నాం. What is epsilon here? Epsilon nothing but delta. Somebody taken as epsilon, somebody taken as delta. Whatever our choice. It's a small quantity. It's a small quantity. Epsilon is a small quantity. Choice of ours. I take as epsilon as 0.1. Somebody take as 0.2. Somebody take as 0.01. Somebody take as 1 also. Somebody take as 1 also. Okay. So the neighborhood of 2 will be, the neighborhood of 2 will be 1, 2, 3. But it is a very higher dimension. But don't worry, somebody it's required, is it required, then they will take accordingly. It's required. Okay. Then they will take accordingly. Okay. Okay. Right.
Yes, sir. Okay, sir.
So now we go for functions of n independent variables. Functions of n independent variables. So how functions will happen in case of functions of n independent variables? Okay now. See, let d be the, let somebody taken as d, let d be the n tuples of real numbers, n tuples of real numbers. That is the d is in r power n. Okay na? R power n. Okay. So a real valued function, a real valued function a real valued function f d to r defined by f of x1, x2 and so on xn equal to w for all x1, x2 and so on xn is in D. So మనం జనరల్ గా సింగిల్ వేరియబుల్ అయితే ఎలా రాస్తామో ఫంక్షన్ f of x equal to y అని రాస్తాం, అవునా? ఫంక్షన్ ఓకే. Okay. So for all n tuples, here also would like to write the same, but for all n tuples, it assigns a single real number. It assigns a single real number. Okay, that okay. So defined by okay f of x1, x2 and so on xn equal to w. W is a real number. Okay. So where d, where d, what is d here? D is nothing but n tuples, x1, x2, and so on, xn is okay, domain of A. And W, okay, is in R, is a range of the range of is the range of okay na okay na. So in case of two variables, functions of two variables, how it will be? In case of functions of two variables, so let D equal to x comma y or x1, x2, such that there exists a real valued function f d to r defined by a real valued function, then a real valued function, defined by f d to r is defined by defined by f of x1, x2 equal to some z. F of x1, x2 equal to z. For all x1, x2, x2 is in D. Okay. For all x1, x2 is in D. Okay. Na? So in case of two dimensional, similarly in case of three dimensional, so x1, x2, x3 will be there. Okay. Likewise, it will goes. For example, as you know that 2x plus 3y, okay, equal to 1. This is the function. Okay. Or f of x comma y equal to x square minus y square plus 1. Okay. Plus 1. So f of x comma y equal to plus plus. Okay, plus. So x square minus y square minus 4. Okay. F of x comma y equal to 2x square minus 3y plus 5. Okay. So likewise, these are all functions. Okay. So for example, these are all two-dimensional functions. For example, I can define that 9 minus x square minus y square, which is a two-dimensional function. Okay, which is a two-dimensional function. Okay. So what is the domain of this? Anyone? What is the domain of this? Domain of this. So actually, what is the domain? So as I told you that when we take a n tuple from f d to r, that n tuple is taken as domain. Okay, now, and the real number w is called the range. Okay. Now, in case of root of 9 minus x square minus y square, as you know that in case of real valued function, this will happen only whenever 9 minus x square minus y square is greater than or equal to 0. Okay, now means that 9 greater than or equal to x square plus y square. Means that x square plus y square is less than or equal to 3 square. Okay, now. So what it is called? In terms of the parenting, what it is?
Square.
Circle of radius 3. This is circle of radius 3. X square plus y square equal to 3 square. So which is a circle, center 0, 0 and radius. Okay, now. So what is the range of this? Anyone? This is the domain. Therefore domain is okay. Now. Domain is okay. Now. So what is the range? Range is what? Anyone? What is the range of this?
0 to infinity.
Yeah. So yes, very good. So in case of root all the values from 0 to infinity, not 0 to infinity, 0 to 3 only. 3 దాకే కదా తీసుకుంటాం. ఓకేనా? Maximum ఎక్కడి వరకు ఉంటాయి? If it is increasing 3, then it will be negative. Then that cannot be a real. Okay. So మీరు ఫంక్షన్స్ ఇలా డొమైన్ రేంజ్ కనుక్కోవడం చేశారా PUC-లో?
Yes, sir.
డొమైన్ రేంజ్ కనుక్కోవడం చేశారా PUC-లో? తెలుస్తా.
Yes, sir.
So for example, my f of x comma y is root of y minus x square. What is the domain? Anyone? What is the domain? Anyone?
X comma y.
f of x comma y ఏమి ఇచ్చాడమ్మా? y minus x square. Root ఉన్నప్పుడు domain ఏంటి? This is always positive. Root ఉంటే always y minus x square is greater than or equal to 0. Or equal to 0. Okay na? So what is that? What is that? Y minus x square, y greater than or equal to x square. Y greater than or equal to x square. Okay na? Now what is the range? Anyone? What is the range?
0 to
Range. ఇక్కడ 0 to infinity because of root. Okay na? Because of okay na? So అదే నేను f of x comma y ని ఇలా రాశాను. ln of x plus y. ln of x plus y. What is the domain?
real number.
Log x ఎప్పుడు డిఫైన్ అవుతుందమ్మా? ln x. For what value of x ln x will be defined? Anyone? ln x ఎప్పుడు డిఫైన్ అవుతుంది? Anyone? ln x, ln of minus 1 ఎంత? ln of minus 2 ఎంత? Yes, please. ln of minus 2 ఎంత? We can't define. For x is positive only it is defined. ln 0 undefined. X positive only it is defined. So similarly, ln of x plus y అంటే x plus y greater than 0. X greater than minus 1. Okay, x greater than minus 1. And what is the range? What is ln of x plus y? What is the range? Log range ఏంటమ్మా?
Minus infinity.
Huh?
Minus
please.
infinity to plus infinity.
మైనస్ ఎప్పుడు వస్తుంది చెప్పు? Can you give the example of minus 1? Yes, please. Like 1 by 100, 1 by ln of 1 by 100 అమ్మా, 1 by 10. Okay. ఏమవుతుంది? This is ln of 10 power minus 2. Is minus 2 ln 10. Nothing but negative kada. Something. Okay. ln 10 something. ln 10 something negative. So whatever you said is correct. But you should careful. Is it get or not? Okay. Is it get or not? Okay. Okay. Now sign of xy will be there. Sign of xy will be there. My f is sign of x. What is the domain? Anyone? Sin x domain ఏంటి?
Minus infinity to plus.
ఇక్కడ ఏంటి? x into y అన్నది. Sorry. Not x. So దీనికి ఏంటి? దీనికి కూడా minus infinity to plus. ఓకేనా? Or whole real number. All values it will take, right? All values. The combination of all values also here it will. What is the range? What is the range?
Minus 1 to plus 1.
closed, right? Closed. Here also same. Sine of xy unna, x unna, x square plus y square unna. Any variables unna same. Okay na? Any variables unna same. Okay. Suppose my f is 1 by xy. 1 by x. One by x. What is the domain?
Minus
R
infinity
minus
to
0.
0 union of 0 comma plus infinity.
Simply xy not equal to 0. Domain is xy not equal to 0. 0 కాకూడదు అంతే. xy not equal to 0. Okay na? X into y not equal to 0. Okay. So what is the range? What is the range? Range is r minus 0.
R, sir.
R minus 0. Okay na? Suppose my f is like this. What is the domain? Anyone? So కొన్ని సింపుల్ దీని రాద్దాం.
X is not equal to 1.
1 by x plus y రాస్తాం. తర్వాత దీనికి వెళ్దాం. So what is the domain? Anyone?
X plus y is not equals to 0.
Yeah, x plus y not equal to 0. What is the range? Here also same, x r minus 0. Here also same, r minus 0. Okay na? Is it correct? Any doubts, please? So ఇప్పుడు దీనికి చెప్పండి. Can you tell about this? F equal to square root of x plus y plus 1 by x minus. Anyone?
0 to 1 union 1 to infinity.
Domain. You are telling the domain.
Yes, sir.
ఏంటి? 0 to 1 union 1 to infinity. X not equal to 1. So this is the two variables amma. This is two variables. So single variable చెప్తున్నా అదే చెప్పాను ఇందాక. So domain అంటే ఎలా ఉండాలంటే the domain will be n tuples. So that is what here we write. The domain అనేది n tuples లో ఉండాలి. Range అనేది single r లో ఉండాలి. R single r. ఓకే సింగిల్ r చెప్తున్నాడు. ఇక్కడంతా చూడు. This is r square. Here domain is r square. This is r square. R cross r. R. Okay. So this is xy not equal to 0. Okay. ఇలా ఉండాలి ఇలా. Okay. So x plus y greater than 0. This is what domain. Okay. Here also x r square. Okay. So ఇప్పుడు ఏమవుతుంది డొమైన్ ఎనిమో. సో ఇక్కడ ఒకసారి మీరు అబ్జర్వ్ చేస్తే ఇక్కడ this is root, right? This is root. Root అంటే x plus y plus 1 greater than 0. Equal to also no problem. And coming to the denominator, x minus 1 not equal to 0. x not equal to. So x plus y greater than or equal to -1 and x not equal to. That is the domain. That is the domain. Okay. X plus y greater than or equal to -1 అంటే ఎలా ఉంటది? X plus y greater than or equal to -1 అంటే ఎలా ఉంటదమ్మా? Passes through -1. అవునా? And equal to also there. This is whole greater than. Greater than అంటే this is whole. This is whole. X equal to 1 అంటే this is the line. This is the line. Okay. So by removing this. What is the range for this? What is the range? Anyone range?
0 to
0 ఎక్కడ ఉంది? ఇది -1 ఉంది ఇక్కడ. ఇవన్నీ పాయింట్స్ కదా, ఇవన్నీ కనబడదు.
R minus.
R minus anyone? Something.
Close interval -1, -1.
-1 + 1 ఇంక్లూడ్ అయింది కదా. ఈక్వల్ టు రాసాం కదా ఇక్కడ. ఈక్వల్ టు. ఇక్కడ చూడండి, ఇది ఇలా వెళ్తూ ఉంది. ఎక్కడికి వెళ్తుంది? సపోజ్ ఇది -1, ఇది -2, -3, -4. ఎక్కడికి వెళ్తుంది? ఎక్కడికైనా వెళ్తుంది. ఈ 1 మాత్రం ఇంక్లూడ్ అవ్వదు. ఈ 1 మాత్రం ఇంక్లూడ్. This point is excluding, right? Is it correct? Okay, now.
Okay, sir.
Yeah. So based on this, you should tell the graphs of these curves. Okay, based on this. Suppose we have taken this one, 9 minus x square minus y square greater than 9 minus x square. Suppose I call this as z. Okay, z. Okay, z equal to root of 9 minus x square minus y square. You should aware of this. Okay, how to draw the graph also. It's at least some graphs you should aware how the graph will be. X square plus y square plus z square equal to 9. So what it represents that? Anyone? What it represents? X square plus y square plus z square equal to 9. What is x square plus y square equal to 9?
Circle, sir.
So z add cheste emoutundi?
Yes.
3 dim.
Yeah. That is the sphere of radius 3, but only positive sphere because of, as already we told you that okay, మనం ఏం చెప్పాం, only xy taken positive. Okay, xy taken positive. Okay, this z is always positive. This z is always positive. Okay, z is always positive. This z is always taken by positive values because of root. Okay, so that's why only positive. So this is the shape of this graph. Z equal to root of 9 minus x square minus y square, which is the radius of 3. This is the radius of 3. Okay, now. Okay. So likewise, you should aware of some graphs. Okay, it's not easy, but you practice by some graphs. Well, going on, will let me know some graphs you don't write. Okay, yeah. Next, ఇక్కడ చూడండి. Point చెప్పి. Next, interior point and exterior point, boundary point. Interior point, the point about the region. Okay, position of a point about the region. Position of a point about the region. Okay, na? So interior point. Interior point. Okay. So let R be the region. Let R be the region. Okay. So like oka region undamma. Okay. So ee region lo the neighborhood of any point is always inside this region. Neighborhood of any point. Okay. The neighborhood of any point is inside that region. Okay. Inside that region. Okay. That point is called as interior point. Okay. So ala kakunda the neighborhood of any point entirely lies outside the region, that will call as outside the region. Okay. So alage some part is interior and some part is exterior. Some part is interior and some part is exterior. That is called boundary point. So that is called boundary point. Okay. Okay. So that write down. Okay. Okay. Let R be the region in R square. Okay. In R square. Let P is any point in the region is called as interior point. Any point in the region, okay, is called interior point. Is called interior point. Okay, is called an interior point. Okay, if the neighborhood of that P, n delta of P is always inside the region. Inside the region. Similarly, boundary point. Similarly, boundary point. Okay. If the neighborhood of P, is always having some points are inside, some points are inside, and some points are outside. Some points are outside. Okay, it's called boundary point. It's called boundary point. Okay, it's called boundary point. Next, exterior point. Exterior point ante if neighborhood of P is entirely lies outside the region. Is entirely lies outside the region. It's called exterior point. So based on this point, we'll say any region is open or closed. Very important. This is open and closed regions. Open and closed regions. Okay. Based on these points, okay. Based on position of point, we'll say, okay. So if the region R is said to be open, okay. Every point in the R is interior point. If the region, okay, R is called open. It's called open. Okay. Okay. It's called open. Okay. If every point, okay, is in the region, if every point in the region, is interior point. Okay. In the region R, some points are boundary points. In the region R, okay. The region R, the region is R, okay. The region R, interior points and including all boundary points, is called closed region. It's called closed region. Okay. The region R, interior points and including all boundary points is called closed region. Okay. So today I would like to give you only one example. Tomorrow I will explain detail this. So if I take, okay. So like for example, x square plus y square is less than 3, less than 3 and this whole thing. Okay. So this is called open region. So strictly less than strictly less than that is called open. Okay. La kakunda x square plus y square less than or equal to 3 kanipistundi. X square plus y square less than or equal to 3 kanipistundi. X square plus y square less than or equal to 3. So these are all boundary points. One boundary kuda include chesam. Means equal to kanipiste, less than or equal to kanipiste, that is called closed region. That is called closed region. Okay. Equal to kanipiste, closed down. Okay. Okay. So alage ee concept raskoni stop cheddam. And I'll give you more examples on this and tomorrow. Bounded region. Okay. Bounded region means, okay. Bounded region means a region is bounded, okay. If it is lies, okay, inside the disk of fixed radius. It is lies, okay, inside the disk of fixed radius, okay. So ila unte, this is called bounded. So ala kakunda, this is called bounded. Idi kuda bounded, okay. So if the region is lies inside a disk of fixed radius. The region is inside the disk of fixed radius. Okay. So this is called okay, bounded. Okay. For example, hyperbolic తీసుకుంటాను. Parabolic తీసుకుంటాను. Okay. Parabolic region తీసుకుంటాను. Like this. Okay. So this will be in 2-dimensional. Parabolic is about 2-dimensional. Okay. Or hyperbolic about 2-dimensional. Okay. So like x square minus y square. Okay. Equal to 1. Okay. So this will be -1. This will be +1. So there is no close here. It entirely goes it entirely closes. It entirely goes. Similarly here, it entirely goes. Okay, it is not with fixed radius, bounded with, it is not bounded with fixed radius. Okay, so that's why this is unbounded. But when we take x square plus y square equal to 1, less than or equal to 1, less than 1, okay, x square by a square plus y square by b square less than 1, okay, ఇవన్నీ కూడా so circle అయితే bounded by this, okay, అలాగే ellipse అయితే so like this, okay, like this, okay, this is a, this is b, okay, this is bounded, this is bounded, this is bounded, this is unbounded, okay. So unbounded means unbounded రాసుకుంది. A region which is not bounded. Sorry, a region which is not bounded is called unbounded. A region which is not bounded is called unbounded. Okay. So అందుకని ఇక్కడ కొంచెం మనం కొన్ని గ్రాఫ్స్ ప్రాక్టీస్ చేద్దాం టుమారో. గ్రాఫ్స్ అర్థం అయితేనే ఇవన్నీ అర్థం అవుతాయి. గ్రాఫ్స్ ప్రాక్టీస్ చేద్దాం, దాన్ని బట్టి కొంచెం ఐడియా వస్తుంది. ఎందుకంటే కమింగ్ మాడ్యూల్స్ దట్ విల్ బి ఇంపార్టెంట్. Means the shape of graph will be important. Okay. So that's about today's class. I would like to give more details on tomorrow also. Okay, on this module. So any doubts, please you can ask now. Any doubts?